Hi parents of primary math students, when you receive your child's exam paper, do you notice mistakes even though your child has sketched the models? If this is so, then your child is not getting the right results despite all the efforts put in. Hi, I'm Mr. Chi from Fun Learner School. Today I'm going to share with you how we at Fun Learner School train our students to solve modeling questions in such a way that these no longer become a big problem anymore. To start off, there is actually a difference between the models your child is supposed to know as lower primary and upper primary. There is also a method to sketch models that is faster and more useful. Let me show you using a challenging primary 5 math question. Lisa was thinking of a number. Well, they like to think about numbers all the time, right? Okay, 4/5 of the number is smaller than 1 and 1/7 of itself by 12. What was the number on Lisa's mind? Now, students, when they see this question, the first thing they do is to sketch the model, correct? Yeah, so let's sketch the model like what most students do. First, of course, we have one hole and we're going to sketch out 5 units because it's like, 4/5, right? Okay, yeah, 4/5. Let's mark it out. Now, students have a problem even to conceptualize 7 units within these 5 units. So, some students may figure out that, probably this might be easier if they actually sketch another one hole at the bottom and then they sketch in the 7 parts, roughly all equal size, and then they sketch one more as well. Alright? So it's supposed to be the case where we have 12 here. Now, how are we going to solve this question? It's going to be quite difficult here because you can't really break up the parts into common sets. So what we do is we know that this is a problem. The models are drawn in the wrong way. In this case, the student is actually sketching the counting model. What is counting model? Is when you have to count the number of boxes to show the number of units, and you can see that it becomes confusing when the numbers become a little odd with each other. Counting models are more applicable when students are starting off with modeling as P2, P3 and P4. When they go to P5, they need to progress to another type of model, which is what we call the unitary model. And I'm going to show you how the unitary model looks like. Now, so let's sketch a unitary model. First, we have one full hole. We actually teach our students to put in this double line. You see this double line here? It means one hole. It's going to be really useful and less confusing. I'll show you why later. First, we have a total of 5 units. Okay, this is why it's called unitary model. Alright, and we mark out a certain part here and it becomes 4 units. Can you see that? Now, next, marker at the bottom. Up to here. Can you see that? This is the double line, which means the original number, and this part here is going to be 7. Instead of using units, we call it parts. Alright, 7 parts, because 7 parts is going to be one whole, and we know that it's going to be 1 and 1/7 of itself, which means that this is going to be 1/7. Correct? This is the bottom part here is one whole. At the right side here we have 1/7, which is a fraction. If we are going to convert it to parts, it's going to be, instead of 7 parts, it's going to be 8 parts. Alright, yeah, because 7 parts plus 1 part here will give us 8 parts in total. Now, when we're going to put 12, we can see that 12 is going to be over here. Can you see that? This is 12. So now, how are we going to solve this question? We have a common link between these 5 units and these 7 parts. Of course, the first thing is to ask ourselves, 5 times how many equals to 7 times how many? We can convert them into common units. So it's going to be 5 times 7, 7 times 5. And that will give us something like 35, right? 35 units, okay? But we already have units, we already have parts, and the next thing we're going to use is sets. So we're going to use as 35 sets. Why didn't I use S? Because S looks very much like 5. So I'm going to use E instead, alright? The second letter for the word sets. So 35 sets, and here will be 7 parts times 5 will give us 35 sets as well. And you notice that the units, all we have to times 7 to become the number of sets. So in this case, 4 units times 7 will give us 28 sets. 8 parts, we have to times 5 to give us 40 sets. 40 sets, which is the long part here, 40 sets, is actually longer than 28 sets by 12. Okay, yeah. So what we can do is we can find the difference in the number of sets here, and that will represent 12. So that's what we're going to do, which is to take 40 sets, we minus away 28 sets, that will give us 12 sets. And these 12 sets represents 12. Oh, bingo! That's the way to solve it, right? 12 sets represents 12, so 1 set represents 1. So in this case here, what was the number of Lisa's mind? The full number, as you can see, is represented by 35 sets, and therefore it's going to be 35. Because 35 sets represents 35, and that's it. Now, what was the number of Lisa's mind? 35. That's the answer. So do you notice that when your child is using the right models, he or she is going to solve heuristic questions in a fastest and most reliable manner. Our students have been applying this strategy and have no problems getting a minimum of 70 plus for the math paper. We have a lot more strategies your child can train in to excel in math problem solving skills. Besides the physical classes, we also have online classes that are more convenient and affordable and just as effective on your child's learning. If you find that learning strategies are what your child needs in order to excel in their studies as well as in life, you have come to the right place at Fun Learner School. Click on the link in this post and someone will get in touch with you. This is Mr. Chi signing off. See you around. Bye!